Hi, 7th graders. Today we're taking a look at lesson 8, and it is on page 93 in your book. So go ahead and turn to page 93, and we're going to look at the top of the page, and we're talking about an opposite of a sum and the sum of its opposites. Okay, so it's not a very difficult topic, but it's just kind of a weird in how it's spoken to you. So I'm going to go ahead and just pick a rational number, and we're going to put 7 in here. And not only are we going to put 7, but I'm going to pick a second rational number, and I'm going to pick a -2. So I'm going to put that right here, okay? And then we're going to get the sum. So we look at these two numbers. Are signs same or different? Yeah, they're different. So what are we going to do? Perfect. We're going to subtract. 7 minus 2 is 5. And is a 7 or a 2 a larger number? Right, 7 is, and it's positive, so our answer is positive. So it has this extra box right here, and what it wants us to do is say, what is the opposite of that number? So what's the opposite of the sum of those? Yeah, just a -5, right? That's easy. So the first part is just getting the opposite of that sum. And remember, a sum is the answer to that addition problem. Well, then we're going to go down here to the second part, and it says the opposite of this rational number. Well, what is the opposite of +7? Yeah, -7. And the opposite of -2? +2. Now, when we go to get the sum of these, signs are different. So what are we going to do? Yeah, subtract. And my 7 is a larger number than a 2. And it is a negative, so our answer is -5. And so when we're looking at this, we know that the opposite of a sum, so when we add it together and then we get the opposite of that, it's going to be the same thing as making them opposites at the beginning and then adding them together. So let's go ahead and look at exercise 1. Exercise 1 says, represent the following expression with a single rational number. So we want to go ahead and first way we're going to do it is we're going to do it by getting common denominators. So when we look at our denominators, we have a 5, a 4, and a 5. What do all three of those have in common? What can they go into? Yeah, a 20, right? So I'm going to put a 20. And we're going to go ahead and find out our new numerators. 5 goes into 24 times. 4 times 2 is 8. 4 goes into 25 times. 5 times 1. You got it. And the last one, 5 goes into 24 times. 4 times 3 is 12. Okay, now we have our same coefficient. We didn't change anything. So if it was a positive, it remained positive. If it was negative, it remained negative. Now let's go around the horn to change them to impropers. We have 20 times 2, which is 40, plus 8, 48 over 20. And it was negative, so we continue with the negative. 20 times 3 is 60, plus 5 is 65 twentieths. And it was positive, so we keep it. And the last one, it's already over 20, and we don't have to change it because it's not a mixed number. So we're going to go right in order. Okay, so I'm going to go ahead. We're going to put some parentheses around this. And I have -48 over 20 and positive 65 twentieths. Signs are different, so what are we going to do? Yeah, subtract. We're going to get 17. And is 65 or 48 larger? 65 is, and it's positive, so my answer is going to be 17, and it's positive 20ths, minus 12 20ths. What is 17 20ths take away 12 20ths? Perfect. 5 20ths, which reduces to? Awesome, 1/4. Okay, now I'm going to go ahead and we're going to do the same problem a different way. So on this one, we had common denominators. Okay. And then on this next one, we're going to do it a little different. We're going to do it by regrouping. So we're going to rewrite I'm going to write the problem again. All right, but I notice that we have a fifth here and a fifth here. So what I'm going to do is I'm going to use that commutative property, and I'm going to put them together. Okay, so I'm going to have negative 2 2/5, and then I'm going to take this negative 3/5. Make sure you take that sign with it. And then I'm going to put that in parentheses, and then I'm going to write the rest of my problem. Now, remember that we can reorder these and then add, and we're going to get the same thing. So I have a negative and a negative, okay? So let's go ahead, and when I put this together, since the signs are the same, we're just going to combine them. They're still going to be both negative. I still have my 2, but now I have 2/5 and 3/5, which is 5/5. 5/5 is the same as 1 whole. So I have actually negative 3. So I put all that together. Here was a whole, so I just added it to it. Negative 3 plus 3 1/4. And signs are different, so we subtract, and 3 1/4, take away 3, just leaves us 1/4. Notice we got the same exact thing. So it depends which one is easier for you. Is it easier to have same common denominators or to work with whole numbers and fractions, both? Let's go ahead and look at the next problem. On the next page, this problem is a little bit more, it's here just to show you, is what I should say. It's not really a problem. It says use the number line to model to show and explain and write the opposite of 2 2/5 as a sum of 2 rational numbers. What it's showing you on the right side of this lower line shows me that I have 2 as one number and then 2/5 as a separate number. Okay, so they're just showing you that having the 2 pieces is the same thing. Up here, we show that we have a whole number and a fraction, and we're putting them together. So this side is pretty easy, basic. Once we go on the left side of our number line, though, they're showing us that if we have 2 2/5, negative 2 2/5, we can just take the opposite and then just add the numbers. So we're still adding 2 plus 2/5 and getting 2 2/5, but then we take the opposite of that, which would be negative. And the lower one shows you that we have a negative 2, and then we have a negative 2/5, which then when we put those together, we have the negative 2 2/5. So all of this is showing you the same thing. Let's go down below to exercise 2. Exercise 2 says, rewrite each mixed number as the sum of 2 signed numbers. So I'm just breaking this apart. So the first one would say negative 9 plus, because we want the sum, a negative 5/8. B would say negative 2 plus 1/2. Oops, sorry, negative 1/2. C says just an 8 plus 11/12. Look down on exercise 3. Now exercise 3 switches us back. We're given what we were doing in exercise 2. So now we're going the other direction. when we look at exercise 3, we know that we have same signs and they're both negative, so we keep the negative, and then we just add. What is 1 and 5/12? Well, yep, 1 and 5/12. On B, signs are the same, they're both positive. 30 plus an eighth is 30 and 1/8. And C, signs are the same, they're both negative. So we have 17 and 1/9, which is negative 17 and 1/9. Exercise 4 says Mr. Mitchell lost 10 pounds over the summer by jogging each week. By winter, he had gained 5 1/8 pounds. Represent the situation with an expression involving signed numbers. What is the overall change in his weight? So we have to have two things. We're going to write an expression and answer the question. How do I write lost 10 pounds? Good. It's like when we played football, right? And we went backwards and we lost yards. Okay, we lost 10, negative 10. And then in the winter, he gained some. Is that a minus or a positive? Absolutely, it's plus, and he gained 5 1/8. So there is our representation. Now we need to actually solve it. Let's go ahead and break this up. Negative 10 plus 5 plus 1/8. Okay? And we can put this together right here. What is negative 10 and 5? Well, signs are different, so we subtract. Take the sign of the larger, so we have a negative 5. So now I have negative 5 and a positive 1/8. Negative 5 and positive 1/8 has to be less than negative 5, or actually greater than negative 5. Now, I want to point out, if we had a vertical number line, and here would be 0, we would have negative 1, negative 2, negative 3, negative 4, negative 5. So I am at negative 5 right now, and I'm adding to that, so I'm going up. Am I adding a whole number? I'm not, right? I'm only adding a fraction. So I know that once I solve this, my answer has to be between there. Okay? I know it has to be. So it's got to be at least a negative 4 and then some fraction. Well, I'm going to go ahead and zoom in on that. Okay? And so here is my negative 4. Here is my negative 5. If I'm talking about eighths, which I am, I need 7 cuts, which is 8 spaces. 1, 2, 3, 4, 5, 6, 7. There's my 8 spaces. If I only get to add from my negative 5 and go up 1 of those spaces, there's my 1/8. If I was reading going the other direction, I pass the 4 and I go down how many? Well, I go down 7 out of the 8 spaces. So my answer then would be negative 4 and 7/8. All right, now exercise 5 says, Jamal is completing let's go back up here and let's put a label on this because it says, what was his overall change? He still lost 4 7/8 pounds. Okay, so make sure we put a label. Jamal is completing a math problem and represents the expression negative 5 5/7 plus 8 minus 3 2/7 with a single rational number as shown in the steps below. Justify each of his steps, then show another way to solve the problem. All right, so he has already done the problem for us. You're not really solving it. You are you're justifying it. You're proving it, showing that it's right. So in this first step, okay, the first thing, what did he do to get from the original problem to this problem. If you notice, he moved that, right? So what was that? Okay, it is, we use the commutative property, right? So we would write commutative property of addition. I know it's addition because I am adding. There's my addition, okay? Okay, now what did we do next? Well, if you notice, we changed stuff, right? Do you see how we broke that apart, and so that we could add the opposite of 5/7 in order for us to keep it? So what we did here was the opposite of a sum is the sum of its opposites. Opposite of a sum is the sum of opposites. Okay, and then in the next one, what did we do here? Looks like we put this and this together, right? That's what it looks like to me. Do you guys agree? Absolutely. So we applied that commutative property again. Of addition again. And then we went ahead and we put those together. So we had right here a negative 5/7 and negative 2/7, which equaled that -1. And now we're gonna put some stuff together. Okay, and what can we put together here? Yeah, we're gonna use the associative property. Associative property of addition. And what does the associative property mean? What did that mean? Well, if we look, we can put parentheses around any two things to do that first. Okay, so we put our parentheses, we put this together. Okay, so we now have -6 and a -3 still, plus 8. So that was our associative. And now what are we going to do? Okay, on number 6, what can we do here? Yeah, we're going to go ahead and put these two together again, right? So at this point, we're just putting them together. The associative property again got us our -8, or -9, I'm sorry, plus 8. And then we could put those together. So these are just adding, okay? This is what I was telling you about earlier, which is going to have, or come in handy as you get through more of the math, because in high school, you're going to actually have to do this as you're solving problems often. So I know it's not very exciting, but I know you can do it. Let's head back to the classroom.